Hello friends, myself Dr. Nandakumar Raubawale from College of Engineering Ambazogai is going to deal with numerical methods in mechanical engineering. This is our fifth lecture. In previous lecture we have seen how error propagates and function of a single variable and how the error propagation takes place in a function of a single variable. Then numerical on error propagation, then data uncertainty, roots of equation, bracketing method, introduction to bracketing method, and graphical method to find the root of a equation using bracketing method. Today we are going to see the numerical to find root of equation using bisection method. So today we are going to study first in brief a bisection method, and then we are going to proceed to find the root of equation using bisection method. So now, what is this bisection method? If there is a function f of x which changes its sign by substituting two values of x, say once we substitute x1, then it yields positive value, and if we substitute x2 value, it yields negative value. That is, function f of x1 is positive and function f of x2 is negative. This value is not negative, this is not positive. X1 is some value, a real value, and x2 is also a real value. If we substitute in the function, once it yields positive and once it yields negative, that indicates the root of equation lies between x1 and x2. So answer of this is between x1 and x2. So when it is possible, if f of x is real and continuous in the interval xl to xu, xl is lower limit and xu is upper limit. So this root we assume approximate, that lower limit of root is xl and upper limit of root is xu, and f of x1 and f of xu have opposite signs. So right now we have seen once it is xl, if we substitute xl positive, if we substitute xu, if it is negative, or if we substitute xu as positive and xl as negative, then these two functions have got opposite signs. Now that is f of x1 into f of xl into f of xu is less than 0, means product of these two, one is positive and another is negative, means definitely product will be negative. So in such cases bisection method can be used. There is at least one real root between lower xl to upper xu, that is root is in between. So this bisection method is going to have the bracketing, means it is going to decide the range in between. This is xl and xu, so the root is going to lie. So to refine these values, here we are going to take average of these two. So revised value of x is taken as xl plus of xu divided by 2. Average value we are going to take, and after taking average value we are going to find out f of xr, say. So if f of xr is positive, if f of xr initially, say for example f of xl is negative, say, and f of xu is positive, now average of these two we are going to take, and then we are going to find out f of xr. So if this is positive, this xu is replaced by xr, and if this is negative, then xl is replaced by xr. So if it is positive, this replaces xu, and if it is negative, it is going to replace xl. So by doing so, answer is refined. Gradually we are going to trap, say for example a root lies here, true root lies between these two xl and xu. We are taking average of a refined value. So xr is a refined value, and that is obtained as xl plus of xu divided by 2, average of these two. Therefore it is known as a bisection method. So now we will consider one function f of c. So where c is the variable, So this is giving the velocity of parachute, g into m. G is acceleration due to gravity, m is mass of parachute, and c is nothing but the velocity. What we say, this is a velocity of parachute. So c divided by m into t minus of b. So this is the equation. We want to find out root, that is nothing but value of c. So we want to find out value of c. So this is unknown, say. So now g is given as 9.8, m is given as 68.1, and v is given as 40, t is given as time, that is 10 seconds, and true value of c is given. So initially we assume that we don't know true value of c, and stopping criteria is when the error comes below 5%, then we have to stop the iteration. On substituting these values in equation number 1, say equation number 1, substituting value of gm, we get 667.38, 1 minus of e to the power of, so c divided by m, c we don't know but t we know, t divided by m, m value is 68. So this gets simplified as 0.146843 into c minus of 40. So equation number 2 is used. Now we want to find out the roots of equation number 1 using bisection method. Say here we consider two values initially, say for example c is equal to 12. So when we substitute c is equal to 12 in this above equation, then f of c becomes 6.06. we call this as a lower limit, and we consider another value of c as 16. This is upper limit, upper value, and f of c at this time, f of 16, if we substitute, this becomes negative. So value of c is 12, we call this as a xl, and upper value xu is 16. So when we substitute xl, this becomes positive. When we substitute upper limit xu is equal to 16, function becomes negative, that is nothing but on substituting c is equal to 16 in above equation, this becomes minus 2.26. So now we will see the table here. xl is the lower limit, xu is the upper limit. So just now we have considered lower limit as 12, upper limit as 16. So here we substitute 12 and upper limit we consider as 16. So now we are going to fill up this table. So to fill up this table, so here xl we are going to consider 12, xu we are going to consider 16, then function is given as f of c is equal to 667.38 divided by c in bracket 1 minus e to the power of minus 0.146843 into c bracket close minus of 40. So now we find out f of 12. So if we substitute lower limit in this, so 667.38 divided by 12 in bracket 1 minus e to the power of minus 0.146843 into c value is 12, closing this bracket minus 40, and this gives f of 12 is equal to 6.06. On simplification, this gives us 6.06. Now we want to find out, this is positive value, this is positive value. Now we find out f of 16. So f of 16 is nothing but 667.38 divided by 16 in this bracket 1 minus e to the power of minus 0.146843 into 16 minus of 40. So f of 16 on simplification, this works out to be minus 2.26. So now this is negative. Now coming back to the table, we have to substitute these values in the table. 12 is positive, f of 16 is negative. So here f of 12 which we have obtained is 6.06. just you can see 6.06. f of 12 is 6.06. f of 16 is minus 2.26. f of 16 is minus 2.26. Now to find out a revised value, a refined root of the equation. So these are the two roots which are not accurate. True value or true root is already given in this problem as 14.7802. this is true answer, but these roots 12 and 16 are not true roots, so these have got error. So to refine this, we have to take average of this 12 and 16. So xr is equal to xl plus of xu divided by 2. So xl is 12 and xu is 16 divided by 2, average works out to be 40. So now f of 14 we find out. F of 14 if we substitute in this equation number 1, say, so f of 14 is nothing but 667.38 divided by 14, 1 minus e to the power of minus 0.146843 into 14, close this bracket, minus 40. On simplification, f of 14 is equal to 1.568. f of 14 is 1.568. so revised answer or revised root, so this was lower limit, this was upper limit, and this is revised answer or refined answer. So we want to assume that this is 12, answer is root is 12 and this is 16, and true root is somewhere here. This value of true root is 14.7802. 14.7802. So now initially we assume that answer is 12 or root is 12 and 16. Now after that, after refining, we are getting that answer root is somewhere here. So he is going to say that it is 14. So 12 is lower limit, 16 is upper limit, and 14 is revised answer, and true answer is here 14. So we want to approach to this 14. So gradually we are moving towards answer from both the sides. So now earlier it was 16, now we have moved to 14 and true answer is 14.78. still there is a error. So now we can substitute these values in this. So xr is equal to 14 and f of xr which we have calculated here, f of xr is 1.568. 1.568. now this is also positive. So now you can see this is positive, this is positive, it will replace positive value, means here this was positive, earlier positive is 16.06 and new positive is 1.568. so now we are going to replace lower limit 12 by 14. So here, so this we are going to substitute as 14 because this is positive, this is positive. A revised value of root is 14 and positive function value is 1.568. now this lower limit is replaced, earlier it was 12, now it is 14 because this answer is positive. Positive value replaces lower limit and negative value replaces higher limit. So again this we copy as it is 16 minus 2.26. So now this is again we call this as a lower root, this is upper root, and this is a positive value, and this is negative value. Again we take average of this 14 and 16. So if we take average of 14 and 16, it will be 15. So revised root is 15 now. Earlier it was 14, now revised root is 15. So we can see here, earlier we were at 16, then we moved to 14, now we are moving to 15. Answer is between 14 and 15, that is 14.7802. So answer is between 15 and 14. So here it is 15, here it is 14. We can see here 12. Earlier it was 16. True answer is 14.7802, and we had obtained 14. Now we have obtained 15. Answer is between 14 and 15. That means we are going to trap our answer. Gradually we are moving towards answer. Our answer is here. So earlier we were saying that root is 16 or 12. So then we obtained answer, new answer as 14, new root as 14. And afterwards we have obtained a new root as 15. So answer is between 14 and 15, or root is between 14 and 15. Gradually we are going to trap this answer from both these sides. Gradually we are moving. Now f of 14, f of 15 we have to find out. Function f of c is equal to 667.38 divided by c 1 minus e to the power of minus 0.146843 into c minus of 40. So now revised root which we have obtained is, just you can see 15. How we obtained 15? So here xl plus of xu divided by 2 is a revised root, and xl was, if we see here, xl is 14 and xu is 16 now. So 14 and 16, 14 plus 16 divided by 2, this will be 15. So now to find out f of 15, we can get 667.38 divided by 15, 1 minus e to the power of minus 0.146843 into c value is 15, closing this bracket, minus 40. So this f of 15 works out to be, f of 15 works out as minus 0.424, minus 0.424, minus 0.424. So we can see here minus 0.424. Simultaneously we have to find out error. So approximate error at initial stage we cannot find out, because here in this we do not have the true value or approximate value, first estimate we do not have. So or else we can say this cannot be calculated, but true error can be obtained. So first step, true error. So this is the approximate value obtained, and true value is known 14.7802. So true error we can obtain. So here true error first we will obtain. First true error, first step, true error. True value is 14.7802 minus the revised value which we have obtained is 14. So revised value is 14 divided by 14.7802 into 100. So on simplification we get this error as 5.5 279%. So true error in this first case is 5.279. Now we can find out approximate error. So earlier approximation was 14, new approximation is 15. So approximate error can be obtained as approximate error is 14 minus 15 divided by 15, which works out into 100, works out to be 6.66%. 6.66%. So approximate error in this case is 6.66%. So to which extent we have to do calculations? So here one condition is given in the problem. Stopping criteria is 0.5%. When this error or this error both falls below 0.5, then we have to stop. Now true error we can find out. So now new approximation is 15. So to find out true value is 14.7802 minus new approximation is 15 divided by 14.7802 into 100. So now on simplification, this true error works out to be 1.487. So this true error we can substitute here as 1.487. So now again here this is negative. Once it is negative, it will replace upper limit. So this is 15 and minus value is minus 0.424. So this is positive will carry forward 14, 1.568. So now this is XL and this is XU. By substituting XL we are getting positive, by substituting XU we are getting negative. Now revised value we can get. So if we take average of 14 and 15, it will be 14.5. So how to take this? Again, revised XR is equal to 14 plus of 15 divided by 2. This works out to be 14.5. So this 14.5 we have taken. Then again f of XR by substituting 14.5 in this original equation. So in this equation we get f of 14.5 as 667.38 whole divided by 14.5 in bracket 1 minus e to the power of minus 0.146843 into 14.5 minus of 40. So this works out 14.5 we are at third stage, I think. Okay, so if we find out this, it will be 0.552. this is positive 0.552. so this will be 0.552. so this is positive, it replaces first. So 14.5, this is positive is replaced by a refined or a revised value 0.552. so this 15 as it is, because this is negative, minus 0.424. so just you must remember, if this is positive then these two numbers will go in first column. If these two are this is negative, then these two will come into the second set. So here you must remember it was negative, so this is going to replace upper limit. This is positive, is replacing lower limit. So now again we have to find out approximate error. Earlier value was 15, new value is 14.5. Approximate error we can find out. So here to find out approximate error, earlier 15, revised value 14.5. approximate error, (15 minus 14.5 divided by 15 into 100, which is equal to approximate error 3.44%. So here we can write approximate error as 3.44%. Now true error we have to find out. So revised value of root is 14.5. So revised value is 14.5. So true error can be obtained. True value is 14.7802 minus 14.5 divided by 14.7802 into 100. So this true error works out as 1.896%. So still it is more than 1.896. 1.896. This is error. Now again, to find out refined value between 14 and 15, so we have to take average of XU and XL. So XL is 14.5, XU is 15, XR 14.5 plus of 15 divided by 2, which is equal to 14.75. 14.75. So here we get this as 14.75 revised value. Now we have to find out f of XR. So again we come back to this f of 14.75. So again we use this equation 1. So 667.38 divided by 14.75 in bracket 1 minus e to the power of minus 0.146843 into 14.75 minus of 40. Sound simplification, this works out as 0.058. 0.058. This is positive. 0.058. 0.058. Now we have to find out approximate error. So earlier approximation was 14.5, new approximation is 14.75. so approximate error 14. Earlier approximate 14.5, 14.75. 14.5 minus 14.75 divided by 14.5 into 100. Modulus of this we take always positive. Then approximate error works out to be 1.695%. So here this approximate error is 1.695. Now true error we can find out. So new approximation is 14.75. True error, true value is 14.7802 minus 14.75 divided by 14.7802 into 100. Again true error works out as 0.204%. 0.204%. So this is now below 0.5%, but approximate error is still above 1. So true error 0.204. So now this is positive. This f of xr is positive, then it replaces this lower limit 14.75.058, then upper limit is 15 and minus 0.424. Now a new value of XR we can find out. Average of 14.75 and 15. So XR is equal to 14.75 plus of 15. 14.75 plus of 15 divided by 2. So average of these two is 14.875. So revised root or new approximation is 14.875. Now f of XR, function value at revised root, can be obtained as f of 14.875, which is equal to 667.38 divided by 14.875 in bracket 1 minus e to the power of minus 0.146843 into C value is 14.875, close this bracket, minus 40, which is equal to, at 14.875 minus 0.184, this is negative value. We can substitute it here, which is minus 0.184. Now we can find out approximate error. Earlier approximation was 14.75, new approximation is 14.875. so approximate error earlier was 14.75 minus revised is 14.875 divided by 14.75 into 100. Okay, 1 minute. Okay, let us see. This works out as 0.840. Just a minute. Okay. So approximate error here is 0.840. Now true error, so this is new approximation and true value is already known to us. True error is equal to 14.7802, this is true value, minus of refined value is 14.875 divided by 14.7802 into 100. So this works out as 0.641%, 0.641%. So true error we get as 0.641. Now this is negative. As this is negative, it replaces upper limit. So upper limit 14.875. If this is positive, it replaces lower limit. If it is negative, it replaces upper limit. So minus 0.184. So this lower limit is carry forwarded as it is 14.75.058. So now average of these two, 14.875 and 14.75, gives us a revised root or new approximation we can call as XR is equal to 14.75 plus of 14.875 divided by 2, which is equal to 14.8125. So this is a revised function or a revised root of the function. So now we can write it here, 14.8125 approximate what you say, this sorry 14, okay. So this is a revised root which we obtained. Now substituting this 14.8125 in the function value, we get the f of 14.8125, which is equal to 667.38 divided by 14.8125, 1 minus e to the power of minus 0.146843 into 14.8125, close this bracket, minus 40. So on simplification, this yields as minus 0.062, minus 0.062. So this is minus 0.062. Now approximate error can be obtained. So previous approximation was 14.875, new approximation is 14.8125. So we can find out approximate error. Approximate error is equal to, previous was 14.875 and revised is 14.8125 divided by earlier was 14.875 into 100. So this approximate error works out to be 0.422. So here this is approximate error. Then true error we can find out. True value is 14.7802 minus new approximation which we obtained is 14.8125 divided by true value is 14.7802 into 100. So this gives us true error as 0.219. So now you can see here both the errors. Approximate error is below 0.5% and true error is also below 0.5%. So now approximate error we write in this table. Approximate error is 0.422 and true error is 0.219. So this error value, both error values have fall below 0.5%. Now this new approximation, which is 14.8125, is going to yield the error in the root of equation is below 0.5%. Approximate error is 0.4 and true error is 0.219. So we can stop here and we conclude here that the root of equation is 14.8125, which is 0.219% away from the true value. Again we can continue this, still this can be reduced. So this is how we are going to obtain the revised approximation from two initial guesses. So this was initial guess. By substituting 12 in the function, we got positive value and another was negative value. So from these two, we took the average of these two, bisected the sum of these two, and then we obtained one more function value. This is positive. If it is positive, it replaces lower limit. If it is negative, it replaces upper limit. So by doing so, we have moved in the forward direction. First we have to approximate. This is our duty, to find out the two approximations in such a way that if one approximation we substitute, function has to yield positive value, and by substituting another approximation, function has to yield negative value. Then we can proceed, because this is a bracketing method. Gradually we trap the answer between these upper limit and lower limit. So answer is 14.8125, which is between 12 and 16. So if we know true value, then we can find out true error. Otherwise this column is not possible to maintain in this solution. So this is the systematic way how we can simplify this problem. So rest of the calculations can be done here, but this table can be filled systematically, so that the paper assessor can have the clear idea about the solution that you have carried out. So these calculations are necessary, but how these calculations are made, that you must know. Okay, so from these calculations we are going to fill up this table. So first approximate error cannot be obtained, because this is first approximation, and we this is first approximation. We cannot compare it with true value. If we compare it with true value, then this will be true error. So this is the first approximation which we have obtained, therefore we cannot find out the first approximate error. But after first iteration, in second iteration we got second approximate value and first approximate value, then we can find out this approximate error. So for true error we need true value and refined or revised function root of the function. So then we can find out this true error. So formula for true error you know, as well as a formula for approximate error is also known. So this is how we are going to simplify a equation and to find out the root by using bisection method.